On this week's MetPy Monday, learn how to speed up your batch processing jobs by using multiprocessing. Use more cores on your machine, get the same amount of work done faster. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. On this week's MetPy Monday, we're going to talk a little bit about multiprocessing, which is something that we get a lot of support tickets about. It's a little confusing to use and understand, and this is going to be just a very high-level, simple introduction, but we're going to do some real useful work. So for today's exercise, we're going to take the mean of relative humidity, air temperature, and wind speed from some Oklahoma Mesonet data files. So if I go over here to my data folder, you'll see that I have in the neighborhood of 20 data files sitting here. These are time series from a given day. And what we want to do is find the mean of those three variables for each of those. This isn't going to take that long for your computer to do. In fact, it could do it all in about 1/10 of a second. So we're going to do it 1,000 times for each one to go ahead and help stretch out that processing time so you can really see the advantages that multiprocessing can have without us having to spend a long time cooking up an example that has long run times. So let's get straight into it. If you are unfamiliar with pandas, I encourage you to go back and look at some of our tutorials on pandas. We've actually worked on reading Mesonet data files before. We've also looked at pathlib, which we'll be using today, over several weeks. So if any of this looks unfamiliar, go back and have a look at those MetPy Mondays. The first thing that I'm going to do is create a path object to my data. So it is in the data directory. I know that the column names for the first few columns, the ones that I care about, are the station ID, the station number, time, relative humidity, air temperature, and wind speed. And you got to make sure you have the right number of single quotes there. All right. So I'm going to write a for loop inside a for loop. And I know I've said before that for loops are bad, but for going over many files, this is really going to be the best way to do it. So I'm going to create a dictionary called mean values that's going to store everything, the mean values for all the stations. So I'm going to make that an empty dictionary. And then I'm going to loop over all of the file names. So for fname in datapath.glob. And remember, if this looks unfamiliar, go back and look at our pathlib tutorials. I want to get all of the MTS, or Mesonet time series files. So for each of those files, I'm going to create an empty dictionary called station means. And then I'm going to read the file. I believe when I've shown this before, I've used read table, but Pandas has recently made the decision to use read CSV and deprecate read table. You just specify the separator to read CSV. So we have our file name. We want to delimit on white space. I'm going to skip 3 rows of header information. I'm going to use calls range 6, that's calls 0, 1, 2, 3, 4, 5, which correspond with ID through wind speed. And names are call names that we defined earlier. Now inside this loop, I'm going to have a second loop for column in df.column. So this is going to iterate over each column in that file now that we've read it in. And we want to only calculate the mean for things that it makes sense. It doesn't make sense to calculate the mean station ID or the mean station number or the mean time. So we're only going to do relative humidity, air temperature, and wind speed. So I'm going to say if column not in ID, number, time. So these are the things we do not want to use. So if it is not one of those, then we want to go ahead and calculate the mean and put it in our station mean. So station means, the column name will be the key. If you're not familiar with dictionaries, again, we've got some great episodes on that. And we calculate the mean of the column. After we've done that for all of those columns, then I'm going to add it to our mean values dictionary. So this will have all the stations in it, not just one. The key I want to be the station name, which is the ID column, and I'm just going to pull out the first element. They're all the same. So data frame, the ID column, the 0th element. So that sets the key to be KOUN or whatever the station name is. And then the value is going to be our station means dictionary. I know this is a little confusing, but it will become much clearer in just a second. So now if I look at mean values, you see that I have a dictionary whose key is a 4-letter station ID and whose value is another dictionary, which the key is the variable name and the value is the mean value of that variable. Now, unfortunately, this doesn't take very long to do. In fact, we could use the timeit command, the timeit cell magic there, and let it run and see how long it takes. So this is going to run it a bunch of times to get a good mean, and it took 109 milliseconds, so about 1/10 of a second to run. That's not very long. We would still see some advantage from multiprocessing, but where you really get that advantage is when the processes take seconds. So what I'm going to do is artificially slow this down some and say for I in range 1000, do that. So this is going to calculate the mean 1,000 times. It's not going to change the result, but it's going to calculate the mean 1,000 times. So that should slow things down significantly. I'm going to take this out of the notebook, and so we can more easily directly compare things, I'm going to go ahead and copy and paste all of this over into a new script. So in JupyterLab here, I'm going to add a text file. I'll go ahead and copy and paste things in and give it a sensible extension. So I'll be right back. So because of a couple quirks in how IPython shell handles multiprocessing, and to try to be as cross-platform compliant as I can, we're going to import the time module. So I've already done that in our analysis.py script. And the start is going to be time.time. At the bottom, the end is time.time, and then we're going to print end minus start. So I've modified this script to now be a multiprocessing script. So let's go over that. To do this, I pulled out the core work into a function called getStationMeans. So it takes the file path. All the code in there is the exact same as what we had before. And at the end, I'm returning a list, the first element of which is the station ID, the second element of which is the dictionary of the station mean values. Now to record all of that, I've still got my means dictionary, but I made a little function called record means that takes the result, which will be this, unpacks it into station ID and station means, and then adds it into the dictionary. Here's where we get into the meat of multiprocessing and why I did all of that, and where a lot of folks make errors. One is they forget to return results. Another is they don't protect the main body of code with this if dunder name equals dunder main. This is because we don't want every time this Python file gets called by a different process in multiprocessing, the whole pool to be generated over again. It will generate errors, and they are a little tricky to track down. So notice I've got my timing hacks in here, just like I did in the other program. Then we import multiprocessing. We get our data path the same as usual. But this is new. So we're using the context manager with multiprocessing.pool. Processes equals 6. This is saying that I want to have 6 processes running at once as lowercase p pool. This is the exact same as it was in our other one. We're looping over every file name in that glob. And now we call this apply async. So this means for each of those things, create a task in the pool that can run asynchronously. It depends on nothing else, and it doesn't matter when it finishes. Get station means is the function that we're going to call. These are its arguments, which is the file name. And when it's done, we take its result and we return it to the callback function, record means. That's what actually holds the ledger for all of these different processes that are going on. Then we call pool.close to say we're done adding things to the pool, and pool.join to say wait here until all of the processes in the pool have finished. Then we exit the context manager. Those resources are freed up, and we print the time. So we've done all of the work. This really creates a pool of processes that when one finishes, the next thing that's out there in the queue gets sucked in and worked on until it finishes, until there's nothing left in the queue. So you might say, well, if I have a 6-core processor, this goes 6 times as fast. That's not really true. You never get that kind of perfect speed up. And in this case, there's going to be some more overhead because we're importing multiprocessing and we weren't before. There's also advantages to longer running calculations instead of our 1,000 iterative calculations. So this isn't the best speed up, but we should still get a pretty significant change. So let's go back to our Anaconda prompt. And since we added the timing, to be fair, we're going to run both of them. So analysis was our without multiprocessing script. Takes a little bit to run. And I'm going to go ahead and run it 2 times so we can see if one of the readings is a fluke or not. So we have 7.7 seconds there, 7.6 there. Now let's run analysis multiprocessing. It should take less time. All right, 3 seconds. Run it again, 3.2. So we cut our time a little over in half, which isn't bad if this took a long time. Now, if you're doing something where you're opening files, doing a rather intensive operation on that data, and then maybe writing it back out, I have seen huge speedups. Things that took hours and hours or even days were done in an hour or 2 using multiprocessing. So I hope that you found this very basic introduction to multiprocessing useful. As you can see, it's a little weird to wrap your head around, and there are definitely some traps for folks that haven't used it before. But give it a shot and let us know how it goes. You can always get a hold of Unidata support using the links down in the description. I'll see you on next week's MetPy Monday.